Hello friends, welcome back to my channel Quality Magnify India. Myself Deepak Kumar Shamal. Welcome all the subscribers and viewers to my channel. We are continuing with APA 653 courses, out of which we already completed APA 650 and 653, which will cover around more than 110 questions. So as I told you, you have to practice APA 650 and 653 regularly and make notes so that you can secure lot of passing percentage from these two courses only. But that doesn't mean other courses like 571, 651, 652, 577, 576, ASME section 5, section 9 are not important. They are also same importance. They are also carry the same importance as APA 650 and 653. If you only read 650 and 653 and believe you can pass the exam, it's not possible. You have to read APA 651, 652 cathodic protection lining, 571 damage mechanism, 577 weldings, 576 PRB, ASME section 5 NDT and NDE and section 9 welder qualifications. You have to read all this in parallel, because what happened, most of the questions came from there. APA 575 is another one important inspection, but it is more similar like APA 653. We will cover APA 575 also in near future. Okay, but those courses, all these courses, what I will tell, 651, 652, then 571, 575, 576, 577, ASME section 5 and section 9. So these all 8 course, 8 ASME and APA course will carry around 60 to 65 questions. So we will divide, it is more or less each and every course will carry 6 to 8 questions. Maybe some course will higher, some course will lower, but 6 to 8 questions in total. So, but as I told, the most important is 650 and 653. So 650, 653 will read very carefully. Then we'll move on to the one third, rest one third of the course, or we can say one fourth of the course, or one third or one fourth of the question, which we'll discuss in the rest of the slides. So today we'll read about APA 651 cathodic protection. It is a simple chapter. There are few things we need to remember, and after that those questions usually came in the exam. Okay, so APA 651 is cathodic protection, and further we'll read APA 652 lining. Okay, both ways we can protect a tank. So that's why it is very near 650 construction, 651 for cathodic, 652 for lining, then 653 for in-service inspection. You see, it is in a sequence. First construct the tank, then put cathodic or lining, then do the in-service inspection. That's why the code was made 650, 651, 652 and 653. So 651 is cathodic protection of above ground petroleum storage tanks. What do you mean by cathodic protections? Cathodic protection is one of the way to protect the tank from corrosion. We avoid the tank corrosion by either painting, by either giving a insulator, by either doing a lining, by either putting a barrier in between the electrolyte or corroded surface and the tank, or by cathodic protection. So this cathodic protection, what is that? We need to know in this chapter. There are few questions, I will just elaborate, and there are some definitions usually they ask. That's why I put a lot of definitions here which you need to remember, or this open book, sometimes open book and sometimes closed book they are asking. So the purpose of this recommended practice is to present procedure and practice for achieving effective corrosion control on above ground storage tank bottom through the use of cathodic protections. Why he write storage tank bottom, only bottom plate? Okay, if you see the tank, as I told you from the beginning, for placement of a tank, we need to prepare a foundation. This foundation can be soil, can be concrete, can be a ring type, okay, can be by some different type of insulated materials. So the tank bottom is directly connected with the civil foundation, okay, or the ground. So most of the corrosion will happen in the tank bottom only. That doesn't mean there will be no corrosion in the cell. There will be no corrosion in the roof. Yes, there will be corrosion in the roof and in the cell also. But compared to the bottom, in cell how it will corrode? Environmental corrosion will happen. Whatever the liquid it is carrying, for that one also corrosion will happen. For the roof, environmental corrosion will happen. Snow, rain will happen, and if there is no proper drainage system on the roof, then the water will accumulate and can make corrosion. Due to atmosphere also it can make corrosion. So compared to this all elements, the bottom is considered is more critical, and for that reason we need to protect the bottom, storage tank bottom, through use of cathodic protections. Cathodic, why we say cathodic? If a component is cathodic, that means it is not corroding. The corrosion will always happen in the anode. For a corrosion, always you remember there is three things is required: anode, cathode and electrolyte. Okay, the whole chapter consists of these things. Okay, cathodic, anode, cathode, electrolyte. How you have to do the cathodic protection? There is two types of cathodic protections. One is impressed currents, one is sacrificial currents. Okay, so these two things are the total gist of APA 651. Okay, then we go in detail what are the type of corrosion usually happen, how to avoid the corrosion, how to do the impressed current, and how to do the sacrificial anode cathodic protection, how we have to do it. These all things we just go in brief way, and those questions will only come in the exam. They will never ask you in very detail about cathodic protections. Okay, so the scope here it is mentioned that for achieving effective corrosion control, okay, on above ground storage tanks bottoms through the use of cathodic protection. So this procedure is for the storage tank bottom through the use of cathodic protections. So these are some of the definitions I have put here. Chapter 3 usually there are definitions. Okay, above ground storage tanks. What is called above ground storage tanks? Now, an on-grade stationary uniformly supported container, usually cylindrical in shape, consisting of a metal roof, cell, bottom and support structure where more than 90% of the tank surface is above surface grade, is called above ground storage tanks. Why I put all these definitions? Because you will find two questions. Usually I face many times. You will find two questions from this definition of APA 651 and APA 652. There is no detailed questions asking to go for a calculation of impressed current. They will never ask like that. It is a very simple question. As I told you, APA 651 and 652, there is 4 to 6 questions you can expect each code, out of which 2 questions you will get from the definitions. Rest 2 questions I will tell you on the next chapter, in the next slides. Okay, so what is above ground storage tank? What is anode? The electrode of an electrochemical cell at which the oxidation occurs. As I told you, anode is corrode, cathode never corrodes. If you make a tank cathodic, that means it is protected. If in any way the tank become cathodic to anodic, then the tank will start corroded. So you have to remember it very clearly. The concept you have to remember: anode always corrode. If you make a metallic piece anode and another one metallic piece cathode, and you will connect it with some electrolyte connection, then you will see the anode is corroding, not the cathode. Okay, anode bed consists of one or more anodes installed below the earth surface, is called anode beds. Backfill. Backfill means if you make a tank and if you make a civil foundation upon which you will place the tank, so the area under the civil foundation which is backfilled and upon which the tank is placing is called backfill or backfill material. Then cathode, the electrode of an electrolyte cell at which reduction reaction occurs. Reduction reaction occurs at a cathode and it never corroded. Okay, Antonyms is opposite word is anode. Cathodic protection, a technique to reduce corrosion of a metal surface by making the entire surface the cathode of an electrochemical cell is called cathodic protection. Chim or chin. Chim or chin is same like protection of a bottom plate. It is called chim or chin. Okay, usually they ask in the closed book questions. The portion of the tank bottom cell floor plate that extends horizontally past outside vertical surface of the cell. Okay, past outside vertical, it is same like a drip ring type of plate. Okay, it is called chim or chin. Coke bridge, a commercial carbonaceous backfill material is called coke bridge. This is not so important, but chim and chin usually they ask. Anode and cathode usually they ask. Concentration corrosion cell usually they ask. A form of localized corrosion initiated by the difference in metal ion or oxygen concentration due to crevice deposits or difference in oxygen concentration of the tank bottom is called concentration corrosion cell. Current density. The current per unit area flowing to or from a metallic surface is called current density. Current density will do in sacrificial impressed current. We calculate the current density in the impressed current type of cathodic protections. Deep anode bed. What is called deep anode bed? Now this is a question usually they come. You have to remember this one. This is closed book questions. One or more anodes installed vertically. Vertically it is installed. Okay, anodes are installed vertically. Okay, at a nominal depth of 15 meter or 50 feet or more below the earth surface in a single drilled hole for the purpose of supplying cathodic protection is called deep anode bed. Very important. 100% they ask this question. I see this question is repeating many times. Deep anode bed, they will put many options, tack 15 meter, 50 feet or more or less, like that. Okay, so keep it, remember, deep anode bed. Differential erection cells, an electromechanical cell, the electromotive force of which is due to the difference in air or oxygen concentration at one part of the tank bottom. Electrochemical cell, a electrochemical system consisting of an anode and a cathode immersed in an electrolyte so as to create an electrical circuit. Electrochemical cell means a liquid where the anode and cathode will make a electrical circuit. Okay. Electrode potential, how much the potential of the electrode? The potential of an electrode are measured against the standard reference electrodes. Whatever the reference electrode is used, based on that the electrode potential will be measured. Electrolyte is the medium. If it is anode and it is cathode, then the media which will touch anode and cathode is called electrolyte, a chemical substance containing ions that migrate in an electric field. For the purpose of RP relative potential, electrolyte refers to the soil or water adjacent to it in contact to the bottom of above ground petroleum storage tanks. Environmental cracking, the brittle fracture of a normally ductile material in which the corrosion, this environmental cracking is different. Brittle fracture happen due to temperature difference. Okay. Galvanic series, a list of metals and alloy arranged according to the relative potential in a given environment. Galvanic series is a list of metal of alloy arranged according to the relative potential in a given environment. Holiday, a discontinuity in a protective coating that exposes the underlying substrate to the environment is called holiday. Impressed current, an electric current supplied by a device employing a power source that is external to the electrolyte system is called impressed currents. This is one important question which is come in the impressed current. What is impressed current? Okay, electric current supplied by a device employing a power source that is external to the electrode system is called impressed current. IR drop, current and resistance. IR is current and resistance. The voltage generated across a resistance by an electric current in accordance to Ohm's law E is equal to IR. For the purpose of RP, the most significant IR drop in the portion of a structure to soil potential caused by current flow through a resistive electrode from the anode to the structure is called IR drop. Oxidation, the loss of electron by a constitution of chemical reactions. This is not so important. Release prevention barrier, this is one of the important one. Includes steel bottoms when used in the bottom, when used in a double bottom or secondary contamination systems. What is release prevention barrier? Usually, sometimes what they do, if this is the tank bottom, okay, to maximize the corrosion intervals, sometimes they put double bottoms, okay, double bottom. They're using double bottom plates, okay, or in between the tank and the foundation they use complete concrete which will make a barrier. There will be no soil contaminations, so the corrosion will be avoided. This is called release prevention barrier. Shallow anode bed, this is again important. This is coming in the closed book questions always. A group of cathodic protection anodes installed individually, spaced uniformly, and typically buried less than 6 meters below grade is called shallow anode bed. If it is below 6 meters, then it is called shallow anode bed. Okay, deep anode bed is more than 15. Okay, 15 meter, and it is 6 meter. Shunt, a conductor of a known electrical resistance through which current flow may be determined by measurement of voltage. Okay. Stray current is another one question. What is stray current? When we put some impressed current, if nearby there is another one metallic equipment is there, and the anodic reaction is not happening properly, then instead of protecting the tank, it will start corroding the tank. That is called stray current. Current flowing through the path other than the intended circuit. If the circuit was made and the current should pass through that circuit to protect the tank, and in between them, if there is a different material came and the current is flowing through that different material, then it is called stray current. Okay. So these are not so important. Tank pad, the material immediately adjacent to the exterior cell bottom of the above ground storage tank is called tank pad. Water bottoms, a water layer in the bottom of the tank caused by separation of water and product due to the difference in solubility and specific gravity is called water bottoms. Okay. So corrosion of above ground storage tanks. Corrosion may be defined as the deterioration of a metal resulting from a reaction with its environmental corrosion of steel structure in an electromechanical process. For the corrosion process to occur, areas with different electrical potentials must exist in the metal surface. These areas must be electrically connected and in contact with the electrolyte. There are 4 components required for the corrosion cell: an anode, cathode, metallic path connecting the anode and cathode, and an electrolyte. So as I told at the beginning, this is concept. There is no question will come. Okay, I will just explain the concept. The concept is you need an anode, you need a cathode, you need a metallic path, the medium, maybe soil or something like that, and an electrolyte, maybe the water or something like that. Okay, if all these are connected, then the corrosion will start, and the corrosion will happen in anode only. Okay, that's why we put a sacrifice anode, okay, which will sacrifice its life to save the cathodic element. So this is anode area, okay, and this is the cathode area. This is a complete steel materials, okay. This is the electrolyte. So current, this is iron, the current is flowing from anode to cathode area, and it is, there is a chemical formula for this one. I didn't explain it here because this is useless to explain. This is not never come in the exam. Okay. So there are many forms of corrosion. The two most common types relative to the tank bottoms are general and localized corrosions. In general corrosion, thousands of microscopic corrosion cells occur at an area of the metal surface, resulting in relative uniform metal loss. In localizing corrosion, the individual corrosion cells are larger and distinct anodic and cathodic areas can be identified. Okay, these are only for the information, questions in exam. So oxygen concentration cell caused by rocks and clays. Okay, this is another one important thing. Sorry. Less the oxygen will be more the cathodic, more the corrosion. Okay, well, that's what it is saying. Oxygen concentration. Physical and chemical properties of the electrolyte also influence the location of cathodic and anodic areas on the metal surface. For example, differing oxygen concentration between areas on a steel surface may generate difference in potentials. So areas, this one you have to remember, areas with lower oxygen concentration become anodic. Anodic means, as I told, it will corrode fast. So the area which is less corrosion, it will corrode fast. This is a closed book questions. Okay, it will come in the closed book, so remember it. okay, and the areas with higher oxygen concentration become cathodic. Cathodic means it will not corrode. Stray current, as I told you, you will get most possibly what is stray current. They will ask you the definition, they will ask you the stray current, what is stray current. In the figure already it is mentioned, okay. Rectifier, okay, we put rectifier to make AC to DC, okay. This is called impressed current, not sacrificial current. It is impressed current. Sacrificial anode means one anode is there is no rectifier will be there, okay. I will read it in next slides, okay. And this is a impressed current. In impressed current, they will put a rectifier which will convert from AC to DC. Then we have to put a product line and we have to protect the tank. But in between that, okay, this product line is going near to the tank. We didn't saw that, okay, and there is a anode bed here connected, so it should protect. But the product line is connected to the tank, which is very near, and we didn't identify. That's why whenever we do any cathodic protection, we need to do a survey of nearby underground equipments also. What are the underground equipments? Then we have to measure every 6 months whatever the potential of the currents. Is it okay what we have set, or it is different? Then based on that we have to find out whether the stray current is there or not. If stray current is there, that means the cathodic protection is not working, okay. Here it is written, these currents are generated from grounded DC electric systems including electric railroads, subways, welding machines, impressed current cathodic protection systems, and thermoelectric generators. These are the areas where stray current will come. Let's read. Stray current, also known as interference current, travel through the soil electrolyte and onto the structure for which they are not intended. It is intended for tank, but they don't travel to the tank. There is another one underground equipment which is very near to them. Then instead of going to the tank, they are traveling to the nearby equipment and they are protecting it. At the same way, tank also get a signal that he need to protect the nearby equipments, because we are sending continuously currents, okay. The electrolytes are flowing, so in that case the tank will corrode very faster. So that is called straight current, okay. They are not intended. Usually the affected structure collect the interface currents from the electrolyte. The source of this current is not electrically connected to the affected structures. Galvanic corrosion is simple. Galvanic corrosions, we have to find out which metal is more noble, okay. Galvanic corrosion occurs when two metals, if there is two metals with the different compositions, thus different electrolytic potentials are connected to the electrolyte, current will flow from the more active metal anode to the less active metals. So if there is two equal type of metals are installed used down the soil, and one is more electrolyte, okay, an electrolyte is more active metal, which is, if there is a more active metal and there is a less active metal, then the less active metal will be cathodic and the more active metal will be anodic, and corrosion will be happen very faster. This is not a question, this is only for understanding. New above ground storage tanks, existing above ground storage tanks, and what do you mean by new above ground and existing? New above ground, the tank is already existing there, and you need to do a calculation to find out what is the cathodic protection. You need to do it. Existing, you have to go for a inspection of the remaining thickness and everything. Then you have to find out how much cathodic protection you have to do it. This is not so important, and it is for your knowledge only. Limitations of external cathodic protections. This is maybe one open book questions. Cathodic protection is an effective means of corrosion control only if it is possible to pass electric current between the anode and cathode, okay. If there is rock, the tank foundation is rock, this is the tank, and downside the tank foundation it is rock, the electrolyte will never flow, okay. Many factors can either reduce or eliminate the flow of electric current, and therefore the limit of effectiveness of cathodic protection in some cases is not used, okay. So such factors include tank pads such as concrete. If the tank pad is complete concrete, as I told you, rock or concrete, it cannot flow. And non-conductive external liner, if it is given, then it will never flow. High resistivity soil, coarse or large rock aggregate beds. If there is high resistivity, resistivity means resistance to electricity, okay, resistivity. Old above ground storage tanks, bottoms left in place when the new bottom is installed. So those areas, this cathodic protection will not work. It may come one open book questions, okay. Tank history. Before determining the need of cathodic protection, a full evaluation of tank history is advised, because you need to do the nearby equipments check. You have to do whether there is any nearby equipments or not. What is the history of tank? What type of liquid? What type of product it is carrying? What is the corrosion rate? Okay, all these things you need to find out. Then only you have to decide for the cathodic protections. Tank pad and soil conditions. You have to check the soil condition because soil carry the electrolyte. Different type of pads are constructed for above ground storage tanks due to wide variety of surface, subsurface and climate condition. The pad material under the tank has a significant effect on external corrosion of the tank bottom and can influence the effectiveness and applicability of external cathodic protection. It is very important to ensure that there is no debris such as rock, lumps or clay, welding electrodes, paper, plastic, wood, etc. in the pad materials. Maybe this is one open book questions. Okay. Rest is not so important. Tanks should be built on an elevated berm to allow adequate drainage away from the tank bottom. The use of fine particle will provide a denser pad. This is not so important. This one maybe it will come as a open or close book questions. Okay. You have to make sure this product should not be there in the tank bottom. This is a table, usually it come in the open book exam. Okay. Resistivity, if it is less than 500, soil resistivity. When it is saying resistivity, soil resistivity. You cannot check the flow, the intensity or something like that. You have to check the resistivity. How much resistivity in the soil? If it is less than 500 ohm per cm, then it is very corrosive. If it is 500 to 1000, then corrosive, 1000 to 2000 moderately corrosive, and 2000 to 10,000 mildly corrosive, and less than 10,000 is progressively less corrosive. So you have to go for the higher numbers. Okay. In coastal areas, salt spray and tank surface will be washed down the sides of the tank by rain and may flow beneath to the tank of contamination on the tank bed. This also can occur in areas where fertilizer and chemicals may be used. So this is not so important. I just put it for your knowledge. You can read it and have some idea how it happens. But in the exam, maybe possible you will get these questions as an open book. Okay, they will put soil resistivity having 750 is ABCD. Corrosive, very corrosive, mildly corrosive, progressively corrosive. You have to come to the table and find it. Okay, you have to go for APA 651. Sand pad. Sand pad, what we are saying, usually whenever we bring some sand, the chloride level should be reduced and then they need to wash the sands. They call it single wash, double wash, triple wash in order to remove the contamination, in order to remove the chloride level, in order to remove the chemicals. Okay, so that the less chemicals, the less chloride, the less contamination connected with the tank pad will be less corrosive for the tank pad. So clean sand is the most common material used on the pad beneath the above ground storage tank bottoms. The use of clean sand alone normally does not eliminate the need for cathodic protection, since corrosion may occur due to the intrusion of water from rain, snow and shallow water. Table consideration and other corrosion described in section 4. Sand pad materials. What are the sand pad materials? The sand should be clean, screened and debris free. That is no wood, sticks, vegetations, papers, rocks, clay, sheet. Okay. Cleaning should be done at the supply source and is accomplished by the mechanical washings. Usually they put the sand in a screen and they put water spray on top of this one so that the chemicals, the rocks, the clays which are stick to the sand, it should be washed away. Okay. Portland cement at an approximate 33:1 sand to cement ratio or lime at an approximate 95 to 5% sand to lime ratio is sometimes added to the supply source of elevated pH levels. If the pH is too high, then we have to control it by putting some cements. Okay, it will make a bond on the top of the sand so that the pH will be controlled. So here there is pH requirements. This was one time asked in the closed book questions. Okay, measuring pH indicates the hydrogen ion content of the soil. Corrosion of steel is fairly independent of pH when it is in the range of 5 to 8. The 5 to 8 is acceptable. Okay, this is asked in the closed book. The rate of corrosion increases applicably when pH is less than 5 and decreased when pH is greater than 8. This is a closed book question again. It will increase if it is less than 5. It will decrease alkaline, more alkaline. Okay, more than pH more than 8, it will be decreased. So this is not so important. Then other factors affecting cathodic protections. What are the other factors affecting? This is a closed book questions. Okay, you have to remember this one. The corrosion rate of steel may double with every 10 degrees centigrade increase in temperature above 25 degrees centigrade. Above 25 degrees centigrade, any addition of 10 degree will double the steel, will double the corrosion rate. Okay, so this is called one of the closed book questions. So release prevention barrier, already I have told to you release prevention barrier, what is that, how we can increase the corrosion rate by putting a dual bottom tank design or some non-metallic or non-conductive membranes we can use, or conductive or non-conductive liner or RPBs, release prevention barriers we can use, so that the prevention barrier can be strengthened. Cathodic protection for corrosion controls. This is one of the, sometimes they ask in the galvanic system how will do the cathodic protections. As simple as I told you, you have to find it the less potentials materials, so that you can install if there is a high potential material and there is a low potential. Let's say the tank bottom is high potential and you choose a anode low potential, then it will corrode fast compared to the tank. So this is like a simple chart, you have to see it and you have to decide. It usually not come in the exam. Impressed current. In impressed current, what we do, we use a rectifier. Okay, in this rectifier we convert AC to DC. I will explain you here. Cathodic protection rectifiers. A typical cathodic protection rectifier has two major components: a step down transformer to reduce the AC supply voltage, rectifying elements to convert AC input to DC output. Units may be obtained with either selenium or silicon rectifier elements. Silicon rectifiers are generally more efficient, however they are more susceptible to damage from power sources. Okay, so it is not recommended if ambient temperature are expected to exceed 55 degrees centigrade. So rectifiers are not recommended if the ambient temperature is more than 55 degrees centigrade. And as I told you friends, this is important points. And measurement techniques, this is only for your reference, you have to check it how to do the measurements. And measurement, usually they define it, here it is not defined. Okay, the measurement is usually defined whether you have to take it 6 months or 1 year, and up to how many months you have to keep the record. This is not so important. Inspection, testing and maintenance. Inspection, test and cathodic protection facilities should be made to ensure that proper operation and maintenance should be done. All sources and impressed currents should be checked at interval not exceeding 2 months. So 2 months is the recommendation as per APA 651, specified otherwise by regulations. See, if the local jurisdiction say or the supplier says 6 months, you have to go for 6 months. Okay, but here not exceeding 2 months. Evidence of proper function may be current output, normal power consumption, a signal indicating normal operation, or satisfactory electrical state of the protected structure. A satisfactory comparison between the rectifier operation or a bi-monthly basis and a rectifier operation during the annual survey implies the protected status of affected structure is similar. All impressed current protection facilities should be inspected annually as part of the preventive maintenance program to minimize in-service failures. Okay, so in total, if I summarize, this chapter is very simple chapter, and whatever the points I have highlighted for the possible questions it will come in the exam, you will read those points, definitely out of 6 you can find 4 to 5 questions, and this is enough to crack your exam. Okay, and rest of the things for your knowledge, you can read it and you can use in your day-to-day life. Okay, so those things for knowledge improvements, but the questions already I've highlighted, and I hope you will concentrate on those questions and you will practice those questions. Thank you friends watching for the video. I hope you are sharing the videos with your friend who are watching my previous videos and getting benefited from it. Please like, subscribe and comment the videos and share with your friends in order to grow this channel. Thank you very much for your time. Thanks.